Alright, I'm going to show you how to graph a quadratic function. We've dealt with this stuff before when we factored and did the quadratic formula, included the square and stuff like that. The only difference is this f of x right here. Now don't let that confuse you. That can be a y. There's no difference between that and this. Okay, it's just the way it's presented. So the first step in graphing this is to go ahead and get the vertex. Now there's a way to do this by hand, and I'll show you that real quick. So we have f of x equals x squared minus 6x plus 5. The way to do this by hand, not using the calculator, is this little formula, negative b over 2a. Using that, that's going to give you half of our vertex. So when you get the answer to this, that's going to give you the x term of our vertex, which is like our starting point to our graph. So remember, we have an a, b, and a c of every function. So our b term is a negative 6. So I'm going to plug it in the formula. Got a negative 6 over 2 times a, which is, that invisible 1 right there. So that simplifies to 6 over 2. And 6 divided by 2 is 3. So the first term in our vertex is this 3, and so we'll put it right here. Now obviously we need the y to be able to plot it on our graph over here. So to get the y, what we're going to do is we're going to plug the 3 in for the x's in the function. So I'm going to do this. I'm going to say y equals 3 squared minus 6 times 3 plus 5. And then we'll just work that out. So 3 squared is 9. Negative 6 times 3 is negative 18. And we got our plus 5 out there on the end. All right, 9 minus 18 is 9. Negative 9, my bad. Plus 5. So negative 9 plus 5 is negative 4. So y equals negative 4. And we'll put that up here. So right now our vertex is 3, negative 4. So what I'm going to do is I'm going to go ahead and plot that on my graph. So I'm going to go over 1, 2, 3, down 1, 2, 3, 4. And that is my first point of my graph. Now, before we had these calculators, what we would do is we would sit here with this XY table, and we would say, all right, well, I plugged in 3 for X, and I got negative 4 for Y. And then we just go through numbers, and we'd plug in 2 and see what we get for Y, and we plug in 1 and see what we get for Y. But we don't have to do that because we have a calculator that'll do all that for us. So here's what we're going to do with your calculator. Get it out, hit your table, and right here, once you hit table, it should say Y equals, and it may say enter function in X, or it may not. Just kind of depends. So what we're going to do is we're going to enter in our function right here. So I have X squared minus 6x plus 5. Hit enter. This is not really something you want to change. Start, I usually start it at 0, but that really doesn't matter. Step needs to be at 1, and it should be on auto. And you'll just go to OK. The first thing I want to find is my vertex. So our vertex was that 3, negative 4. So I'll go down here. All right, so there's 3, negative 4. And you're going to notice something interesting over here on the y side. You'll see how with the y, there's a negative 3 above it and a negative 3 below it. Now, once you've done this a few times, you'll see that you can find the vertex without actually doing that math. You can look at your calculator, and when you look on the y column, you'll see the vertex will always be sandwiched in between the same numbers. So if you look through here, you don't see any numbers repeating themselves until you get right here where you see both those negative 3's. Whatever the term in the middle is, that's your vertex. But for right now, we can find it by hand. What I want to do is I want to plot 5 points. So I've already got the vertex on there. That's our first point. That's 1. So now I'm going to go ahead and plot the point above it, 2, negative 3. So 1, 2, 1, 2, 3. And then I'm going to go up 1 and plot that point, 1, 0. So 1, 0. I'm going to go down. I'm going to plot the 2 points below the vertex, which would be 3, 4, negative 1, 2, 3. and 5 zeros. So 1, 2, 3, 4, 5, 0. So you see I kind of got a shape here. And so I can go ahead and draw in. This is called a parabola. And it's just kind of this curved shape. All these graphs should look pretty similar. Maybe some are skinny and some are wide, but all pretty similar. So there's our function graph. That's what the graph looks like. And you know, we could plot any of these points we wanted, and all those points would be on this graph somewhere, even if it extended way up here. But as long as we have kind of the general shape, that's what we need. So the next thing you're going to be asked to do is you're going to be asked to find the y-intercept. Y-intercept. And that's kind of exactly what it sounds like. It's where this graph crosses the y-axis, the y-intercept. And that's something else that you can find in your calculator. So if you look back at your table, what we're going to look for in here is wherever x is 0. So I'm looking on this side. I'm going to scroll up, and there's x where x is 0. This point, 0, 5, that is our y-intercept. So that's where the graph crosses the y-axis. So y-intercept of 0, 5. Now sometimes you'll see it on the graph, sometimes you won't, depends on how high up or how low it is. But that one is pretty easy to find, and it can always be found by finding where x is 0. Something else you're going to be asked to find is called the axis of symmetry. Symmetry means, you know, kind of equal on both sides. So if you look at our graph, we see that if we drew a line right down the middle, this graph would be symmetrical. Right? It's the same on both sides. I could take it and I could kind of fold it over and it would look the same. That is our axis of symmetry. Okay? And what they're going to ask for is they're going to ask for the equation of the axis of symmetry. Now that's a line. And to write the equation, all you have to do is see where the line crosses the x-axis, so it crosses it at 3. And what you're going to write is x equals 3. That is your equation for your axis of symmetry. So that's pretty simple. Another thing they're going to ask for is whether this graph has a maximum or a minimum. And they're going to ask for its value. All right, this is a pretty easy concept. When you look at your graph, if it looks like ours does, it's like a U shape, that has a minimum point. Think of like down here, this is the minimum point of that graph. So what you do to find the value of it is you think, all right, well, this thing, the minimum is -1, -2, -3, -4. That's as low as it goes. And that's how far it goes down. So our graph has a minimum of -4. Right? Now, obviously, to get a maximum, this graph would need to be flipped. It would, need to look like, I like to say it looks like a mountain. Okay? A mountain has a maximum point, and then a valley has a minimum point. So that's how you determine that. The last thing, and probably one of the hardest things we're going to talk about right now, is finding the x-intercepts. Now we've talked about these before, and I know something y'all love so much, this quadratic formula is used to find the x-intercepts. You would plug in your function into the quadratic formula and you can solve, and the two answers are your x-intercepts. But with most graphs, like this one right here, we can just look and see. So x-intercepts, where the graph intercepts the x-axis. And I see one time it does it right here at the point 1, 0. And then another time it does it right here. That looks like 1, 2, 3, 4, 5, 0. So those are your x-intercepts. Another way to find them is to look at our calculator again. And to find x-intercepts, we can look and find where y is 0. So you see right here, y is 0, x is 1. Well, there's that point. And then let's keep going down. There's our other one. Y is 0, x is 5. There's that point. So those are your x-intercepts. And that's just kind of the basics on how to graph one. I may make another video and show you how to graph a few more, and soon we'll do a different form, and I'll show you how to do that as well.